data science. It's not just for the big guys. Today's presenter, David Spyra, has over 25 years in business strategy and data and enjoys working with the small business community, helping them thrive. David, thank you very much for your time. I'd like to turn this over to you now.
Yeah, thank you, Tom. And I wanted to first just thank the Chamber of Commerce. It's an honor to be able to talk, and I'm a proud member of the Commerce and a proud member of the Issaquah community. All right, let me get my slide show up here for you. I can't talk and click at the same time without messing up. So there we go. All right, you can see that, Tom? Okay, good. So I always just start what is data science all about? You hear the phrase all the time in the press and the news. And it's really been around a while. So, the pieces of it, what you're seeing now is a lot of pieces coming together. So it is an interdisciplinary field. That means that it has components of multiple fields that are a nexus together. And it's really become powerful because the advent of a lot of data here called big data, because it gets to be large data sets, advances the computing power, and it being able to pull things together and provide insights that it wouldn't have before. So when you have skills across all those things and you have teams that can work across all those things, that's the phrase data science. So how do data scientists think, and how does that help your business? That's what I'm going to walk you through today. Basically think out loud on on 5 different themes for you. And with those themes, those are ways of thinking about your business that we can go through together. And I'll go through from simple examples today, but there are advanced versions of every one of these, and there are many, many more themes. The idea is to start adding a powerful skill to your business, and whether that's for a small business or a startup, or for a department or a function within a large business. It's really the same basic process. So let's start with the first one, and that's uncertainty. So one of the things that we talked about as a skill base for data science is statistics, and looking at things through a probabilistic lens, which just means that data scientists would see things as gray, as looking through the math operation, trying to figure out how something would work, how to make something more predictable, and how to make it more digestible for the purpose of either making a decision or measurement or progressing the business. So uncertainty is one of the #1 things that statisticians and data scientists deal with, and there's different flavors of it, and it's different amounts, and there's different tools that run along to it. So these types of uncertainty you'll see recognized in your business. One is linear, or the smallest one, where you have many of the factors already controlled, but you're trying to get to some level of precision. This is where you have the traditional statistics. This is where you do a model, say how many sales do you have this month, or some sort of forecast, that type of stuff. Branched, you hear about scenario planning, and like, what if I buy that new store? What if what if I buy a new product line? What if, anytime you kind of have those different scenarios that you can choose from, you end up modeling them back and forth. That can be done very simply, just by sitting at your desk and thinking through it, or different scenarios in a spreadsheet. But it can also be ramped up with more complicated modeling, integer programming, optimization techniques, things like that. Ranged means, a low bar and a high bar. A lot of what we look for is asymmetry. Asymmetry means something like no less than this or no more than that. Those are bounded areas, and it lets us guess really well and make good decisions and manage the risks that are associated with it. And then there's unbounded uncertainty. Unbounded is when you really have no idea of where it's going to work. And then that's what we really talk about. How do you frame experiments so you start to reduce the amount of uncertainty for subsequent cycles? So how do you do a pilot or a test run or something like that? Gather the data for your, for your mini product launch or whatever else to get the feedback that you need in order to make a good business decision later on it. Or how do you process lots of raw data and try to get insights into it? That's when you get into the three things we're talking about here, which is designing things up front well, having a test to learn kind of mentality, and having machine learning and kind of pattern recognition. So second one is feedback cycles, right? So we just talked about, especially as we ended with the uncertainty around, how to design things the right way. Getting feedback so you can learn is a huge objective from the data science community. Marketing is a really good example. So I used a marketing process here as how we do it. When I ran the marketing analytics functions at JP Morgan Chase, this is the same way we did it. We designed it, we structured it, we built in experiments, we had test and control groups built in, we had reporting and monitoring, all for the purpose of what worked, what didn't work, how do we measure and how do we get back in? The idea is marketing was an investment. We can measure a return on investment and we can learn from it. And by learning from it, it made it better. And I often talk about in my teaching that the difference between good and great on marketing is the ability to learn. And that's really the key here, is having a process anchored with a structure and a framework, setting things up so that you can drive that learning process faster than others, read from it, and then adjust so that you can turn off things that don't work and you scale up things that do. Third one is an example of working from positive attributes you see with your customer behavior. And that's a mouthful, so I'll unpack that for a second. And that's just saying, what do your customers currently do? In marketing is much more effective, in our view, if you can find some sort of basic behavior that they have unaided, without marketing, without prompts, without encouragement. And then how do you amplify that? So I pulled an example from one of our portfolio businesses here of a campaign that we actually ran. So this is actual, real, marketing campaign here, where it ran for a period of about 4 weeks. We launched it, and what we did was we set up two pieces. We set up a control versus the target population. Target is, in this case, the orange, and the blue is the seasonally adjusted expectation based on the baseline, which we call the control. And what it allows us to see is, yep, we had a behavior. Look at the orange line as it plots along. We had a behavior that existed that got amplified and accelerated in a short burst of time. And basically the difference under that curve is what we call a lift. And that was the impact from the marketing program or the incentive that was put in front of the customer. In this case, it was a 484% lift. And if you take out the underlying growth, because there was kind of year-over-year growth and some seasonality built into it, and that's basically what's in the modeled baseline, that allows you to say that marketing program gave you a return relative to your costs, and it allowed to put basically an ROI on it. So the same kind of idea, if you send out a bunch of letters or if you do A/B testing, is one of the phrases that you'll see coming out of it. It's how do you frame your experiments within your marketing programs so that you get hard data on what's called that incremental lift, because that's the objective in your spend. Otherwise, you don't know if it worked or not, or it's anecdotal and you're guessing. And if you're guessing, it goes back to that feedback loop again. It's not going to get any better, but it works, especially if you can find the underlying behavior there in the data and make it observable and measurable. Fourth one is to use customer insights to tune your business. Now, people, especially entrepreneurs and small business owners, do this all the time, right? They talk to their customers, chat them up, get some feedback. They hear what works. They certainly know what the complaints are, and we get feedback from the customers. But there's little clues all around us. So I thought I'd do is just pull together some of these clues, and then talk about how we use them in order to improve the business a little bit. So one is we had some, if you go out on Google and just search for your business out there, it gives you histograms, which is the little pointed charts here based on time of day. And it says when people are there. What we saw was, we thought we knew what it was based on the patterns based on what we saw in the previous quarter and the previous month. And we were wrong. We were wrong. And the reason we were wrong is we shifted, right? So as the season shifted, as we went from spring to summer to the fall, what we're seeing is a change in the patterns. And this one, intuitively, as we looked in, we scratched our heads, tried to figure it out. And what we saw was during the summers, a lot of our customers go out of town for Fridays and Mondays and things like that. They have long weekends, and it shifted the patterns of when it happens. We also changed some processes inside this particular store, and those processes changed the time of day that the customers were coming. Those things added up for us to tweak what we were doing on our staffing, because we weren't fully aligned to it. So we were getting really busy at the times that we weren't sure, and we were staffing to what the prior pattern was rather than the new pattern. So even though we're plugged in and we watch this, sometimes we have to watch for when the model shifts or the behavior shifts. And then this reinforced, again, I don't think small business owners always go to all the sources they have. So we do, we take credit cards in our business, and our merchant service provider provides data to us on what time of day, the types of transactions, all that type of stuff. So when we look at the Google data, which I'm not even sure how they get it, truthfully, and then I look at the credit card data, I go, well, they generally agree, but we get some more foot traffic in times than we get transaction traffic. So those behaviors are different measured, and we have to kind of work through it. So it gives us some tempering of that to work through what we need to do in terms of having somebody there to serve customers and to keep the lines down, which is a big part of our business model. Here's another piece here, right? So we introduced some technology to get our service deliveries out there, and it moved things up. So it changed the time of day that customers were interacting with us, because they got used to the new change, and we could see the shift. And it shifted where we were basically loading up. In this case, these are lockers, loading up lockers in the morning, and in the afternoon, people were using the lockers. And that behavior was different before, because it was all around lunch previously, where people would load up and come back. So it was really good. And then we looked at one more source. We looked at the telephones. So, we use voice over IP. I'm sure many of you do. And I was able to get the data from our voice over IP vendor, which is fantastic for a relatively small shop of 10 people. We can see the phone calls come in, and we can see when we're answering them and when we don't. And we could see what we had was what I call a natural experiment. Natural experiment, when a data scientist says that's when the framing of that test and control that we talked about earlier happened naturally because of something that was unexpected. In this case, we had some people out sick, and as a result, our normal staffing model wasn't in place. So we were able to observe, and you can see in the red circles where we were short-staffed, and we only had one person in the store that day. And what you saw was a bunch of missed calls. So the combination of being busier than we thought, originally from the trailing data, and not having enough people caused the event that we wanted to avoid, which is longer lines and missed calls, right? And you can think of every one of those could have been, business on the other end that went away and went to a competitor, or, a bid that was, we never quoted on, or something like that. So those are loss events when we don't do a good job answering the phone, and voila, right in front of us are the failures that we're trying to work through. In this case, we know what it was, but the time of day is very important there. Those were occurring right in those little peak spots that both Google and our transaction data were telling us were showing up, especially on the Tuesdays and the Thursdays that got busier than historically we had been. And then same thing with geography. Now, so geography is something that we could pull in again from, credit card data that says, as customers transact with us, where are they coming from? You can't always stop them and get a survey. You don't always know where they're coming in from. You can't check their car and on the way in or anything like that. So we use where they actually live based on their credit card. Now, sometimes that's off. Obviously, people can come in from a business and use a personal card, or the card can have a different address on it than normal. Sometimes, it could be a business card could be in the wife's name or the husband's name. So it does throw off the demographics and some of that stuff, but it's still an important clue. And then we use this for our marketing, because at the end of the day, what we want to do is, again, reflect what the natural draw area is, as opposed to, trying to put seeds in the desert in terms of marketing, that type of stuff. So we're trying to figure out where it makes sense to communicate our message, where our service zones are, and we're trying to use data for it. A great example, thinking about val packs, or we're thinking about geo-targeted, stuff out on social media as for purchasing and things like that. So any of these kind of, inputs that we can gather on a regular basis help us tune that and to get that dialed in. The last one is really a kind of a management discipline process. And sometimes you get this from, just like working in a finance department or something like that, and kind of advanced finance analysis. But data scientists also kind of build on that too, in that we get into what's a customer worth? What's the lifetime value of a customer? And then how do we acquire them, and what is it worth acquiring? So in this case, what we do is we look at a number of aspects, and I'm not going to be able to go through the whole thing here just because, time or whatever, but, kind of go through, I'll give you the overview, and you can always look through the slides later. 12 quarters, 3 years, that's the kind of the, I'll call it the present value calculation. So a 3 years cumulative spend, what we expect from that. And the red line is a cumulative line. That means the longer we keep that customer, the more times they come in, the more repeat their customer behavior is, the more they're worth. And then what you do is you build in your retention rates and your repeat rates and your pricing on those services, on those recurring services, and it gets you to a value. In this case, a customer in this profile that I laid out here is worth about $1,000 to us today, which is kind of a net present value view, given all of those assumptions. And those assumptions are grounded in our data. So we use the past to forecast the future, and then we determine monetarily what that customer's worth. And then what do? We go out and we try to find those customers. So, how do we get $1,000 customers? How much are you willing to spend from a marketing and a promotion type of program to get a brand new $1,000 customer? Part of it is our profitability. We will, to get $1,000 customer, we want to make sure our marketing programs return 100%. So we want to make sure everything that we do on the marketing gets at least what we call a return on marketing investment, which is called ROMI, of 2. 2 is basically a 2-to-1 ratio. And what we're trying to do is to get to the 2s, the 3s, and the 4s, which means we want 100, 200, 300% returns on any marketing we spend, because we're a little firm and we can't afford to, waste our money doing, things that feel good, but don't work. So one of the ways we do that is we put models on things. So, for another example here on the outbound communications. What we do is we try to predict, think of this as like, you know, a letter or a postcard or whatever else. We try to predict who would respond and who's not based on a model. And then if you can stack rank them and put the ones with the highest score, think of it as scoring them all, because that's what a model's doing, and then sorting them so that the top 10%, the top 20% you mail to, those most likely to respond, right? Then what you're doing is you're stacking your deck and you don't bother mailing to the bottom 80%. And then what happens is your lift gets amplified. And this is how marketing works in the real world, because untargeted things don't usually get enough of a response rate to be profitable. If you target them and then tune it with a model of some sort, then you really start to make the progress. And then the other aspect of this is you always work to make that model better. And there's one of the things that we highlight on here is called a champion versus challenger. In this graph, what you can see is the blue line in the middle is the old model, where the green line is the new model. The new model predicts better in that it brings more of the population of acceptors to the front deciles. So it stack ranks them better and then gives you more lift as a result. So, that's, again, a great tool to take a program that works and make it better by making sure that your bullets land on target a whole lot more, and you waste fewer bullets then, right? So that's the keys to how that works. You can use it for scenario analysis. I put one in here where you said, hey, here's two choices. Do you tear down something and rebuild it? Or do you just run the engine on in this case, it was a service, right? Do you just kind of keep running the service? Or do you spend the time to rebuild it? In this case, the present value for rebuilding it was twice as much. And in this case, it was all about knocking costs out and digitizing it. So I had a service that was largely manual. Had a service element to it that I had to pay a vendor for. I digitized that, removed it, and that basically created a lift as an example. So it's just the same math gives you multiple ways to look at a problem and to then potentially solve it. So and with the idea of using that kind of discipline framework for learning, improving, and scaling your business, that's what the data science does for you. So it becomes a little more predictable. All right, so I'm landed right around the 20-minute mark that we needed. So Tom, I'm all ready for whatever questions or whatever else. I know I went fast, but the idea is to give you kind of an overview of how a data scientist would think through things.
Excellent presentation, David. Thank you very much for your time. I really appreciate it. Just being in a community with a lot of small local businesses, that customer lifetime value really, I think, is strategic in the area. Just so important for the small business to see that, if you can get a customer for life, especially here where people are living here generations, you're doing yourself right. We did get a couple questions that came through. The first one is, within the small business community, what is the common misperception of data science?
I think one of the common, I'm sure there's more than one, and I'll go to the strictly business ones, is that it's static, or like technology programming, or it's super costly and unavoidable. And it's basically all those things it's out of reach, right? And I just don't believe that. I believe that that skill set can be brought down and applied at the smallest level, medium level, and is accessible to all of us. So I think it's the inaccessibility and that, and hence the title, only for the big guys, is the myth that I'm trying to bust on that.
Excellent, excellent. And this one came from a small business owner. The question is, before beginning the tuning process, let me read this for it. What is the average time to review a customer's insights before beginning the tuning process within my business?
That's a great question. Not to answer like an economist, but it does depend. It depends a little bit on the mechanism that you're using. So if you're doing something that is observable and measurable in a short period of time, then your tuning and learning process can be quicker. So for instance, Amazon, when they do this and they do their, collaboration kind of engines that allows them to learn, they can learn in, days and weeks. If you do it through, an old fashioned, you get an offer for a mortgage in the mail, and you have to walk then to the branch and then fill that out with a coupon, and then you have to go book that mortgage. It can take like 90 days. So the nature of the business, the nature of the transaction and the observable, as well as the nature of the media and the messaging and the measurability lag to it really drives it more than anything else.
Fantastic. Well, David, thank you very much for your time this afternoon. Greatly appreciated. To all attendees, we will be uploading this presentation on the Chamber YouTube site. So please pass on. This is some valuable information for the local small businesses. Thank you again, everybody. Take care. Bye-bye.
Thank you.